What role does energy conservation play in chemical reactions? Have you ever wondered how energy plays a part in the chemical reactions happening all around us? Energy conservation is a key player in these processes, and it keeps everything balanced. According to the law of conservation of energy, energy cannot be created or destroyed. It can only change forms. This means that during a chemical reaction, the total energy remains constant, even though it may shift between different types. In chemical reactions, energy is stored in the bonds that hold atoms together. When a reaction occurs, these bonds break, and this breaking requires energy, known as activation energy. Once the bonds are broken, new bonds form in the products, and this process often releases energy. If the energy needed to break the bonds is greater than the energy released when new bonds form, the reaction absorbs energy from its surroundings. This type of reaction is called endothermic. On the other hand, if more energy is released than is needed to break the bonds, the reaction releases energy, often in the form of heat, and is called exothermic. This balance of energy is essential for understanding how chemical reactions work. For example, when you burn fuel, you are converting chemical energy into heat energy. However, the total amount of energy remains unchanged throughout this process. Energy conservation is not just a theoretical concept, it has practical applications too. In industries, managing energy changes is vital for producing chemicals efficiently. In living organisms, enzymes serve as catalysts that lower the activation energy needed for reactions. This allows important biological processes to happen at body temperature without needing extra energy. To sum it up, energy conservation in chemical reactions ensures that while energy may shift between forms, like chemical, heat, and kinetic, the total energy stays the same. This principle helps us understand how reactions behave, their energy needs, and the energy they releases. It truly is a fundamental aspect of both thermodynamics and chemistry that affects everything from industrial processes to the workings of our own bodies.